Hello everyone, I'm Gary Williams. This is Ramblings of a Sysadmin, and in this, I have a cup of tea. I have a lab. Also got an assistant sitting down here. Say hello. And in this series, I ramble on about a particular technical topic. Now, today, I want to ramble on about creating CSRs, but specifically creating CSRs in Windows and how you submit those to a certificate signing authority to get back a properly trusted public cert. So I hope you enjoy. So what I thought it would be interesting to do is take Microsoft's next version of Windows, that's Windows Server 2022, or what they're currently calling vNext, and install it, put IIS on now, bring up the default site and put a cert on it. And what I will guarantee is that this process on Windows Server 2022 will work exactly the same all the way back to at least Windows 2003, because Microsoft haven't changed a damn thing within IIS in all of those versions. It is the exact same code. They've not made even any graphical changes. Everything's the same. So I guarantee this is going to work. So as you can see, I've called the server vnext01.gdwnet.com. My internal domain is gdwnet.com, so hence why it's called that. We can see it's not secure, and it has the bog standard Windows IIS default page. Now, I'm not going to add anything in. I'm just going to add the cert onto this IIS page simply because it's the quickest and easiest way to do it. It will just prove that the process works. To get a certificate on here, we need to do several steps. The first thing we have to do is create the CSR. We then need to submit the CSR to a proper CA. I'm going to use my internal CA because, well, I'm cheap and I don't want to spend any money on a cert for a site that will last about 5 minutes. So I'm going to use my internal CA and I'll show you how that works. In the real world, the backend CA would do this automatically with their systems, but the process is exactly the same. Once that's done, it will give me the PEM certs. And then finally, we install the cert, and I'll show you how to do all of that, how to find the cert in the necessary cert stores. I'll even quickly go through the cert stores because they can be quite confusing at first. Once all that's done, we should have IIS available, or the IIS default page available over port 443. So let's give it a go. Right, back in IIS Manager, this is our default website. So this is the one that gives you that horrible blue Microsoft default page. If you come over here, you'll see SSL settings, and you might think you request a certificate through here. You don't. As you can see, there's nothing in here. You can't turn anything on. The site doesn't have an SSL certificate, so we can't do anything there. What we actually have to do is come all the way up here to the server itself and go to server certificates. There's nothing in here, so what we have to do is create a CSR. Now that's going to give us a pretty standard screen that the first time you see, you may go, what the hell is this? And I'll go through all of the options on here, but this is the standard, I think it's called X509. It's basically the standard set of questions that any cert generator will ask you, and you need to fill them in. Most of these don't actually mean anything. The important one is the common name. Pretty much everything else you can ignore. But the common name has to be the name of the site. Organization, who cares? Unit, whatever. City, don't care, doesn't matter. These are just text fields. State, province, doesn't matter. Interestingly enough, the field here, this country region, doesn't actually matter as such, but you can't put UK in there. It has to be GB because only GB is recognized in the official X509 standards. It's one of those oddities that's been around since like the 1970s. So we hit next, select your cryptographic service, don't really care. We can hit the defaults on that. Specify a name for the certificate request. I'm just going to throw this on the desktop and call it IIS CSR. It will take a few seconds to generate, and all this is doing is this is generating a text file. So if I close out of this, There's our text file. Now, what you may realize if you've worked with certs at any point is this looks very similar to an actual certificate. And to be fair, this is why I really like pen files, because you can open the file up and it will actually tell you what it is. This begin and end just says, hey, this is a new certificate request. And inside that is encoded text that tells the CA, here's all the details for the site. This is PF Sense. And one of the things I really like about PF Sense is that I can use the cert authority part of it to act as an internal certificate authority for my domain. So I can play around with certs without having to pay out any money. Now, in the real world, if I've got anything that's hosted out on the internet, I use Let's Encrypt because it's free and they do a damn good job. But in this case, what we would do in the real world is we would take this certificate signing request and would pass it on to a proper certificate authority. Now, before I go any further, there is nothing wrong in using Let's Encrypt. If you can use Let's Encrypt, go for it. Their certs have a validity of 3 months, which is fantastic because you have to get into this whole automated rotation of them, which you should be doing anyway. And they do it also with their Acme cert bot, which just works. So if you can, go use Let's Encrypt. If for some reason you can't and you have to go to a proper cert authority like all the big ones out there that I can't even think of off the top of my head, but you know the ones that I mean. Komodo, I think, is one of them. They'll have a portal that will ask you to paste in the certificate signing request. Basically same as this. So what I'll do is I'll copy that out of the text file. So that's just the CSR from the text file I showed you earlier. Don't worry about these line breaks, just paste it as it is. Don't really care. It's going to be signed with my internal CA certificate. My descriptive name is going to be the name of the server. That can be anything, but I always put the server name in. Key date, I don't have any. Certificate lifetime, 3,650 days. Now, in the real world, you'll get 2 years. There's some talk about reducing that to 1 year. They probably should do it, but that's another video. But by default, it's going to be 2 years. I'm going to set this to 10 days because I don't want anything particularly long on this. Digest algorithm 256, don't care. This is going to be a server certificate. Now, there is a difference between user and server, and it's all in the OIDs. Now, if you know what an OID is, that's fantastic. And basically what happens is you get certain OIDs that say this certificate is a server certificate or a user certificate, or those, what they call the extended validation, the EV certs. It's just an OID in there. If you don't know what an OID is, don't worry about it. It's basically a setting in the cert that says, I am this type of cert. And we need to make sure this is a server certificate. Chances are the proper Komodo type signing authorities already have it set to server certificate. What I'm also going to do is put the vNext name in there. Now, when I created the cert, I put the common name as vnext01gdwnet.com. I'm also going to put it into the alternate names. The alternate names field is also known as a SAN, or a subject alternate name. And what this lets you do is this lets you actually create a certificate that has multiple additional names. And I'll show you a very, very cool feature. So we can also call this something completely different to what the server itself is called. The server can have one name, the website can have one name, but we can call the cert anything we want, and we can keep adding. Doesn't really matter. All this says is this cert belongs to vnext01. However, it will also work quite happily on abcdef.com. One of the things that I did a while back when I was messing around with LDAP certs for domain controllers is I created a cert for one domain controller, and then I just added in all the other domain controller names, the fully quantified names, into the subject alternate name. That way, I didn't need a wildcard cert, but one cert could be used on every single domain controller, and it just worked. And I love that kind of flexibility with certs. I hate wildcard certs because wildcard certs just are an insecure nightmare. You know, if you get hold of it, if you know the domain name, you can go off and create a site and you can have that name and you can do all sorts of stuff. Personally, I prefer using subject alternate names just because you can limit the amount of additional names you give a cert. Anyway, that's enough of me going on about that. You can probably tell that I prefer doing things this way. Now, apologies for graying some of this out. I do need to hide some of these names, unfortunately. But you can see down here, I now have my certificate. And what I can do is export certificate. What I'll also very quickly show you is the certificate above is for WordPress. Now, this is some WordPress testing that I was doing. And you'll see it gives me the option to get the cert and the key. Now, that's not great because you shouldn't have the key with the CA. You should keep hold of the key yourself. You can generate certs directly on the server, so I don't have to mess around with the whole CSR process. In some cases, you don't even need a CSR. The cert authority can do it all for you. But if they do it for you, they're actually generating their own internal CSR, running it through the system, and then giving you both the public and the private key. For the most part, that's not an issue, but if you want to keep your private key private, definitely go down the CSR route, and it's much, much safer. As you can see, I don't have a private key. It's already on the server. It's there when I created the CSR. What will happen is, when I give it the public key, which is generated, that's going to then finish off installing the private part of the key into the server so that it all just works. You can generate certs directly on the server, so I don't have to mess around with the whole CSR process. In some cases, you don't even need a CSR. The cert authority can do it all for you. But if they do it for you, they're actually generating their own internal CSR, running it through the system, and then giving you both the public and the private key. For the most part, that's not an issue, but if you want to keep your private key private, definitely go down the CSR route, and it's much, much safer. As you can see, I don't have a private key. It's already on the server. It's there when I created the CSR. What will happen is, when I give it the public key, which is generated, that's going to then finish off installing the private part of the key into the server so that it all just works. Now, what you may also notice is this has gone yellow. This is a warning. The cert's only got a few days. It's fine. It's for testing. So I've downloaded the cert. Let's go install it. Right. So the cert is on the server. If I open with Notepad, you can see it's this pen format, this lovely text file. So what we do is we come back to server certificates, and this time we hit this complete certificate request. File name containing the certification authority's response. Nothing on the desktop. It's a CRT file. It wants a CER. Doesn't really matter. They're both PEM. I can just click on that. Friendly name is just the name it will display. And select a certificate store. Now this is a strange one, because do you want it in web hosting or personal? It doesn't actually matter. We can throw it in web hosting. We can throw it in personal. And personal, actually, I suppose it does matter a little because personal is the users. The site can still see it and use it. But web hosting is shared. So let's throw it in web hosting. There we go. There is our cert. If I now come down to my site, SSL settings, we still have it grayed out. Why is it grayed out? Because we've not actually assigned this cert to the site. The reason for this is we can have multiple certs. We could have hundreds of certs in here. And IIS doesn't by default know where all of these certs should go. So what we have to do is we have to go to the site itself, edit bindings, add HTTPS, IP address all unassigned. Well, there's only one IP on this box, so it doesn't really matter. Now host name, I'm going to put in the server name, and I am going to turn on require server name indication. Now SNI is this feature of certificates that lets you allow multiple websites on a single server, and it divides them up by their name. And this is where your SNI comes in. So if I tick that, I can have vnext01, I can have vnext02. Now, if you remember when I created the cert, I had all those aliases. I can actually carry on adding additional sites and use the same cert, but use the alternate names that I've got to apply to those sites. These, disable TLS 1.3, don't do it. Disable quick, don't do it. Disable HTTP2, no, don't do it. These are really good security standards, so please don't disable them. Maybe the only one is OCSP stapling, which a lot of people don't like, and it's kind of falling out of favor. If you don't have a particular need to disable anything, just leave them all. Now we can select the cert. We've only got the one cert because we've only got the one cert on the system. So we put that in there. Okay. And close. Now we can come down to the default site, hit SSL, and it's no longer grayed out. Acquire SSL, client certificates. We're not using client certificates. If you remember when I created the cert, it was a server cert, not a client cert. But one thing we can do here is we can actually require client certs. Now what that means is I have to have a cert on my machine to be able to connect to that site. It's like another method of authentication. The person with this cert can access that site. And this is our site. So as you can see, I'm getting an access is denied. That's because I'm actually going to it on plain HTTP. If I do HTTPS, there it is. And that's just how easy it is to put a cert onto an IIS box using a certificate sign-in request. We didn't have to do anything on any private keys. The system took care of it all for us. Just as a side note, if I hit F12, I can see the actual standards of the cert. So we can see it's TLS 1.3. It's got this cipher standard of IIS 256 GCM. You can look these up. That's one of the more secure ones. I think that's the latest and greatest and recommended. And we can view the certificate. Now, something really important to note on here is the certification path. This is coming from the internal CA. My computer trusts the internal CA, so it trusts the cert that's issued here. If I put this server out on the internet with this cert and a person's machine connected to that site who didn't have my internal CA cert, you would get an error message. I'll show you what the error is that you'll get. This is the error that you'd get. Your net error cert authority invalid, because my internal CA is internal to me. I don't want it out on the internet, and I don't want anyone using these certs. These are real certs, but they're not publicly trusted certs. So this is why you have to go through a proper cert authority like Komodo or Let's Encrypt or one of those, because their root certs are trusted by all the computers around the world. And the way that's done is when the machine is deployed, or when the operating system, I should say, is deployed, it already has those certs in the trusted cert store. In fact, you can go into the cert store and delete them, and then all websites become untrusted. I've seen companies do this for additional security. It's a slightly strange one, but you can do it. This is just down to the whole way the trust model works. In fact, if you're really interested, look what happened when the semantic cert was revoked and a whole bunch of websites became untrusted. If you're also interested in the different errors you can get with certs, this badssl.com is a great site to come visit. You can see all the different standards, and I absolutely love it for that. Anyway, I hope this video has been interesting. I hope it's shown you another way you can do secure certificates with certificate signing requests. I'll do a future video where we use OpenSSL for this, and you can see some of the features that you can use with OpenSSL. OpenSSL is more used on Linux, but you can actually use OpenSSL on Linux to generate a cert for Windows. So I'll show you that at some point as well. Anyway, I hope you've liked it. If you have, please do drop a like. It'd be great if you could hit subscribe as well. A lot of the people who are viewing these videos aren't actually subscribed, and it does help the channel. I am trying to grow it, so any help that anyone can give is great. If this has been useful as well, please do put a comment below. If you haven't liked it for any reason, please put a comment below. And if it's been useful, well, there's also a buy me a coffee link, so that would be great. Thanks very much.